In chapter 2, we looked at one equation. In chapter 3 here, we're going to start looking at where you have more than one equation or a system of equations. This first problem on your note sheet says the initial cost for Travis and his band to record their first CD was $1,500. Each CD will cost $4 to produce. So for the first thing, they want us to write an equation then for the cost of the CDs. Well, from what it said, we know that the cost is going to be $1,500 that they have to pay for sure, plus $4 for each CD. So $4 per CD, and that would be the total cost. The next part of it says if they sell CDs for $10 each, how many must they sell before they make a profit? So the second thing they want us to find out is what would be an equation for the income? Okay, well, if we look back at what they said, they sell them for $10 each, so that would just be y equals 10 times however many CDs. So we have these two equations here that talk about the CDs and the money that you make from them. If you look, you do have a graph on yours that shows the situation out. They want us to know, what does this point represent on this graph? So on our graph here, what's this talking about? Okay, what's this point 250 comma 2,500? What is that point talking about? Well, that point would be where where the cost is the same as the income. Cost is the same as the income coming in. That's also sometimes called like the break-even point. That's where the amount of money that they spent to make the CDs equals the amount of income that came in. And if you try it out, it works. If you plug in for this one, for X, 250, you get $2,500. If you plug in 250 on this top equation, what you get is 400 times 250 is 1,000. If you add that to 1,500, you get the same 2,500. So that's the break-even cost. After that, any CDs they sell over 250 would produce a profit. Okay, so we're going to look at situations like this where you got to graph out two graphs and find when are they the same. When's the break-even point? When are they going to be equivalent? All right, then on your note sheet there is a table there, and with systems of equations, when you have two equations with two unknowns, two variables, there's three ways you can solve the system. One of the ways we just looked at was to graph or graphing. Graphing is one way you can solve these equations. Another one that we're going to look at in a little bit here is called substitution. And one final one you may remember from last year, elimination, are the three ways you can solve systems of equations. Also, we're going to look at the types of solutions you can get when you do one of these. One of them we just saw in that first example would be where you get one solution. You get one answer. And you get that when you have intersecting lines. Okay, here's an example down here. On this graph, you can see these two blue lines are crossing at this point. That is the one solution where both are the same. So when two lines cross, you get one solution. Okay, intersecting lines, you get one solution. We also call that consistent and independent. All right, another thing that might happen. You may end up graphing the same line. In that case, we say there is infinite solutions. Infinite solutions. And that's when you end up having the same line on top of each other. Because when you graph the same line, if we have this blue line here and we graph another line that's exactly the same over it, these two lines are touching at every possible point. Every point here is a point where these are touching. So any point on the line would be an answer for both. So we say there's infinite solutions. The last thing that you could get is that there are no solutions. No solutions. And this happens when you get, the only way you'll get two lines to never cross is when you have parallel lines. When lines are parallel, they'll never cross, so you won't get the one solution we had over here. So when they're parallel, since they never intersect, you won't ever get a solution. No solutions. We call that inconsistent. All right, so let's try some out here. First, we'll look at kind of the graphing method when we do this. They want us to solve the system equations by graphing. There's kind of two ways you can do this. You could use the intercepts to do it, or you could get it in slope-intercept form. We'll do one of each again so you can kind of see it. Let's do slope-intercept first with this first line. So we're going to graph this one, we're going to get it in slope-intercept form. Now remember, when you get in slope-intercept form, you went y by itself. So we want to subtract this 2x from the other side to get that to cancel. So we get the equation y equals negative 2x plus 5. Recall that this is the y-intercept. This is our slope in front of the x, and anytime it's a whole number, you can put it over 1. So on this one, if we were going to graph this, we'd start with our y-intercept of 5, put a dot, and then we would proceed to go down 2, because it's negative, right 1. Down 2, right 1. Down 2, right 1. Keep going. Okay? And then we can connect those with a line. That's our first line. All right, now our second line, let's use our other way we talked about graphing, and that would be to find the intercepts. So if we want to find the intercepts, remember we said use that cover-up method. So if we were to cover up the y, what we would get is x equals 1. So that would be the x-intercept at 1. Okay, now instead, if we cover up the x, we get negative y equals 1. Dividing by negative 1 would result in y equals negative 1. So cover-up method could also be used when you're doing these. So y equals negative 1 is the point right here. Connect those, and we have this as our other line. Okay, where is the solution to this one? Remember we said when lines intersect, the solution is where they cross, so where they intersect, being that point right there. That's our one solution. And so our solution is at the point 2, because it's over 2 and up 1. So the solution to this one would be the point 2, 1. That's the answer to this problem. That's where our lines cross. Okay. On this next one, they also want us to graph here. Why don't you try this one out for tomorrow? See if you can do B and see what you get for an answer for B. So you guys try that one out for tomorrow. All right. Next one on the back, number 2. Now we're going to use one of the other methods. We're going to use substitution. When you're doing substitution, what you want to look at first is to get one of the variables by itself in one of the two equations. This one is set up nice for substitution because we already have that. In our top equation, y is equal to something. So you either want to get a y equals equation or an x equals equation to start with. So step 1's already done for us. Second step, now we want to substitute this new equation into the other equation and replace that variable. So we're going to take what y equals here, and we're going to plug that or substitute that in for the y here, since that's what y equals. So that will result in x plus 2 times, and then we put a parenthesis here because we're substituting in for y, 1/2 x minus 18. write the rest of the equation out, equals 18. So now we've made the substitution. Next step. We want to solve for the other variable. So now we want to solve this one out. See what you get when you solve it. So first start out, looks like we need to do some distributing here. So we're going to get x plus 2 times 1/2 is going to be 1 or 1x. 2 times negative 18 would be negative 36. We can combine x's here, that would be 2x. And we could also look at adding 36 to the other side, which would equal 54. Divide by 2, and x equals 27. Great, awesome. So we got that, but we're not quite done. There's one last step. The last step, plug this value into one of the 2 original equations to find the other variable. So we found x, but we still haven't found y. So now we want to plug our answer in for x. And the easiest place we're going to have to plug this one in is probably the top equation, since it's already solved for y, and that's the other variable we need. So plugging that in, you get y equals 1/2. We know that x is 27 from what we just solved, minus 18. Doing a little arithmetic here, 1/2 of 27 minus 18 would be negative 4.5. So we have both our x and y now. For our solution then, it would be the point 27, negative 4.5, and that would be the answer. That's where, if we were to graph these out, that's where the 2 lines would cross. All right, the problem following this one is another problem where we're going to have 2 sets of information. Let's read through it. It says Matthew stopped for gasoline twice on a long car trip. The price of gas at the first station where he stopped was $2.56 per gallon. At the second station, the price was $2.65 per gallon. Matthew bought a total of 36.1 gallons of gasoline and spent $94. How many gallons did Matthew buy at the first station? We need to come up with some equations from this information. One thing you notice they talk about in the problem is a lot of stuff with money, 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 money. So we're going to write an equation that deals with money. Let's also call our first station that they talk about x and our second station y. So we have that the first station, it's $2.56 at station x. Station y is $2.65. And together, if we add up the cost of gas from both, we know it adds up to $94. So that's one equation we got from the information there. We still have some, we still need another equation though, because if you have 2 variables, you need 2 equations. So if we read through this a second time, it says Matthew bought a total of 36.1 gallons. So we need to also have an equation for that. So if we take all the gallons at station X plus all the gallons he buys at station Y, together that should equal 36.1 gallons. Now we have a system of 2 equations, and we can solve this and try to find out how much did he buy at station 1. Now, when you're doing this, this would probably be a good one to do that substitution. We're trying to find X. How much did they find at the first station? X. So if we solve for one of these 2 equations for y and use substitution, we can get it. The easiest equation on this one to solve for y looks like the second equation here. Let's solve that for y. So if we subtract an x from both sides, we get the equation y equals 36.1 minus x. Now use substitution and you can get the answer. For tomorrow, I want you to try this out. So take what we got here, plug that into the first equation for y and see if you can solve that and find out how many gallons. All right, we'll do the rest of your note sheet tomorrow.